We have more and more people coming in. That's great. Hello? Good afternoon, everybody. Shall we start? This is the first time I'm using this technology to broadcast my presentation. I may have some problems, issues, or whatever, but important you learn something from this few hours that you spend with me. I'll be going through everything about E3D. I will be answering the questions that you put in the chat. I hope I can answer all your questions and help you with whatever issues you have. I know some of you are users. Yes, you probably take this opportunity to actually ask me things. Yeah, go ahead. No problem. We won't charge you anything. So at the end of today, everybody goes back happy, and we will organize more of this type of information sharing. Let's start with our agenda today. So I will start by actually doing an E3D overview. And then we look at the 3D modeling. I will show you how E3D is used to model anything in the 3D environment. We will do some analysis like interference checking, data, consistency, check-in, etc. We will take a break. Then we have isometric, GA and report, which I will show you about all the various deliverables that you can get from E3D. And then we have administration. We show you how I can create users, create anything that you want so that you can actually start an E3D project very quickly. E3D projects can be for a few people doing a project to hundreds of people. And then after this we will have your questions. Who are we? We are TDS. We were founded about 10 years ago, actually slightly more than 10 years now. And we do everything about engineering with computing. We provide our E3D training. You can ask us to do catalog and specification services. We do administration for E3D projects. We create plugins. We do software development, and we can do consultation as well. So, that's a quick introduction. So the first thing we want to talk about is about E3D. Alright, for those who do not know what E3D is all about. It's a multidiscipline design tool. That means it has facilities for you to model different things from piping equipment supports, structure, cable, trace, and HVAC. Of course, you can do your concrete walls, your buildings, etc., etc. But they are not very efficient to be done in E3D. But it's still possible. You can also be able to use other software to interface with E3D. Then you can work in a collaborative manner. So how does E3D achieve all it does? It's about a database fine-tuned for plant design. It stores 3D information as well as other information. Someone just asked if we need SQL database. And does it need AutoCAD? Actually, we do not need any of them. All plant information is stored in the database managed by Paragon. Any questions? Okay, if you don't have questions, let's move on. Next, you might think what sort of projects E3D can be used for. We can have very simple tiny projects. For example, some piping if you want to create isometrics. E3D is not cheap, but if it's available, why not use it? 100% of the time. Isogen is expensive for generating isometrics. To do this small project's administration is easy. So we can use it for tiny project. This is what I call tiny project, a few HVAC, a few supports. So you want to create some support drawings, etc. You can also use it for a small skid. With all the structural. Some cable trays, supports electrical, etc. This is the small project. We can have a bigger project where you have modules put together and connected. And lastly, you can have a very huge project. E3D has been doing huge project for many years since 1978. At that time it was PDMS. If you ask veteran E3D designers who are in their 70s, you know a lot of them work on PDMS for the BNFL project. E3D does not stand still. AVEVA Unified Engineering is the future of plant design happening today. AVEVA has consolidated all data and engineering under one database system. 3D plant design, PNID, E and I all share the same data. This database is in the cloud. That means to participate in the project, participant can be added easily and quickly. Alright, is this the future? No, you can purchase Unified Engineering 3.0 now. AVEVA have also added analysis possibilities, like heat and material balance, etc. It is really exciting to be involved with AVEVA. Let's focus on E3D. I want to explain to you how E3D is actually multidiscipline and how everybody can work concurrently. The concept is MDB, or multiple DB. In a project you can have many MDBs, as you can see an example of a typical project. A designer will be assigned to what he needs to do. He selects the MDB assigned for his work, and he starts designer in that MDB. The supervisor who is looking at the full project can have a MDB where he can view all areas. Any changes made in any of the MDB, the supervisor will see the changes. For the designer, he does not need to be concerned about which drawing file to open, etc. Just open the MDB and the system will control which area the designer has access to. Inside each MDB, you have got equipment, piping, support structure, cable trays, etc. All these can be put into every MDB. And anybody with the access rights can update this information. Any update is visible to all in the project. So let's stop these boring PPT and look at E3D. Let's get Thiam on.
Okay, so let me start my E3D. Okay. So far, any questions? Okay, anytime, please. Any questions, just write down. If it's what I'm talking is too easy, also tell me that, okay? If I'm talking too fast, talking too slow, not explaining myself correctly, please let me know, all right? Okay, so I'm going to log into an E3D project. So in E3D, we don't go to a folder to open a DWG. We just actually go to a project. So a project can be, I have many projects here, but if I choose APS, and at the bottom, can you see a reference? So what is, okay, there's question there. I will go back to answer your questions when it is relevant, okay? Okay, so the first thing is that a project can reference other project. Can you see the word reference there? So in E3D, it's very flexible. If your company has got a set of catalog and a set of specification, you put them as a reference project. And the moment anybody runs a project that references this project, he can make use of your catalog. All right, so you just imagine that if you change something in the catalog, people who are using the catalog can get it. And if something becomes obsolete, people who are working on that item can be informed that something they have become obsolete. All right, so this is the reference. So this is quite important. If you manage your E3D properly, this is very helpful for most people. All right. Okay, so to get into a project, you have to use a username and password. Okay, so the database inside E3D belongs to AVEVA E3D. So it is not using Excel, Access, Oracle, or anything like that. So it is actually by itself. Okay, for example, drawing files are also database, but they are not so sophisticated as what we have in E3D. Okay, in fact, this database can also reside in the cloud. Okay, so to start off a project, you have to put in a password. Okay, so a system user is something I have set myself because I'm going to demonstrate all the disciplines. So I've set myself as a system user. But the username and password that you enter will determine what are the areas you can access and not access. All right, then next you have the MDB. So for example, if your company has E3D and you create a blank project that is referencing a standard database, a standard catalog, then you can select, for example, your projects are all very small, about 50 isometrics or, a few equipment, 20 isometrics like that. What you can do, you can put all these small projects, all these small little projects into a single E3D projects, and you use MDB to control which project you want to select. that is one possibility as well. So every time you have a new project, you use this master general project that you can actually create for everybody to use. All right. So for this case, I'm going to go into the MDB. So this is an MDB. So if I go into this demo MDB, I go into the model, and this will go into my 3D module where I will design my 3D. Okay. So back to the questions. This E3D database is actually their own proprietary database. It is not Excel, Access, or anything else that you can buy from I don't know, from some from Amazon.com or something like this. Okay. Mustafa, did that answer your question? Yeah. Okay. So that's one of the people ask me, where is the DWG file, where is Oracle, etc. all the time. But no, E3D doesn't use any of that. All right. Okay, so I'm starting up. Okay. So this is the main module of E3D. All right. Okay. Okay, so this is the main module of E3D. Here you can see a model explorer. And what is a model explorer? It is the explorer that you have for different sites, etc. All right. So the main thing that your user will be getting used to is the site, which means that it actually contains both structures, etc. inside there. So for E3D, you can, if you are only, for example, you're not interested to see the structures, you can hide it, or you can just remove them from the view. So that allows you to quickly unclutter your screen so that you can concentrate on designing. All right. So that's why even for a very big project and you're using a very slow computer, it's still workable because you can restrict what you can see. But restricting what you can see doesn't mean that you won't have any issues if you crash into something that is there, because under your home screen, there's something called auto crash. So when you're routing a pipe, if you hit a beam that's there, it will actually automatically prompt you that it will show you the beam that is there. All right, that's auto crash. Okay, I cannot turn on auto crash for mine because in my project, I have a point cloud project in the background. So if I turn on, that might slow the thing a little bit, or that will show crashes that actually show me the point cloud that I don't want to bother with. All right. So that is the auto crash. Okay. So you can see that right here is the database. So if we go into projects and we go into options, and one of them is to say that, okay, just now that view is for me, what do you call that? A super user. If I'm a normal user, I can just say hide non-user stuff. So you can see that now a lot of things that you see just now has disappeared because those are not important for me. Okay, so this model explorer is a view of the database, but at the same time, you can filter what you can see on the model explorer. Okay, so this is one thing. So you can see that just now, remember, I choose the MDB called A demo, right? Correct. So there are some of you who, can I ask a question? Those who use E3D, how do I change the MDB? Anybody can help me? What should I do to change the MDB? Can somebody just say that, give me some suggestion? Can I have a show of hands? Who are those that are using E3D already? All of you haven't used E3D. I'm sure Mustafa has not used E3D. So, okay, Mustafa is the first one to show hand. Nobody else seems to have used E3D. Okay, so anyway, okay, so this is the first takeaway for today. If you don't want to go to monitor, that means you have to switch the modules to something else called monitor. You can use a command called mdb. And for this case, I don't want to update. So I can say mdb no update. And I change the mdb to another mdb. And now you can see that my things are different. All right. Okay. So just now, one question somebody asked me is that it only detect only structure crash? No, it detect any crashes that you put in the obstruction list. Okay, it detects any crashes that you set up in the obstruction list. Okay, so it doesn't only, when you route a pipe, it doesn't only shows you crashes that goes against you. This is only, auto crash is only happening when you don't turn on the other stuff. You only turn on, you only want to see what you want to have. Okay, so this is one of the things that you can have. Okay, so this is what I think is enough for first portion, which we have half an hour. Then we will move on to modeling. So you have any questions about E3D databases? Okay, so if let's say you go to tools and you call out the catalog, then the catalog viewer is here. You can see all sorts of different catalog. All right. So, and this catalog may be for cable trays, can be for let's say for cable trays, you can see all sorts of catalog for cable trays. Okay. So, so these are all the databases. So in this project, you can see there are a lot of databases. All right. So if you can imagine, each database is something like a table in a traditional database. All right. And basically, I think we can have about 4,000 databases if I'm not correct. If I can remember correctly, we should have about possibility for 4,000 databases. So so you can have a project as big as you can have. Okay. So so far I think the first portion to look at database. Okay. So the last thing is that just now we were in the model modules, and you can see there are the monitor module, which allows you to come back to the center and go to any of the other modules. The isometric modules, okay, the draw module for your 2D drawing, Paragon for your actual catalog and specs, and lastly, spool module. What does a spool module do? It actually allows you to define a isometric drawing. That means you can define the content of the isometric drawings. And why do people do that? Because with the spool module, the well numbers are remembered, the spool numbers are remembered. All right. Okay. Okay. So, okay. Let me come back to the questions after that because I don't quite understand your questions. All right. Okay. So these are the modules. So the takeaway from the first portion of the thing is that you understand what is a foreign project. A foreign project is a project referenced by your current project. So normally, standard catalog and specification, we put it in a foreign project. Okay, so right now, it's like if you take a catalog of piping components, that itself can be in a foreign project. And then your own project is where you put the different piping component into your specification. All right. So this is the difference between, so foreign projects are projects that are basically have got references that can be fixed. All right. Now, E3D consists of many databases, and how they control what you can access is through the team that the user belongs to. So you can have a piping team. So everybody in the piping team can access only the piping and not other discipline like steel, structure, everything. All right. But saying that, E3D can go even lower than that to say that within the piping team, a person can only access water piping or facilities piping, another guy can do process piping, etc. So this is all we can control to that level. All right. Okay, MDB. MDB is to group a few database all together as a single integrated database that you can work on. All right. So as a project administrator, maybe every day a user will use MDBA for what do you call it? Like for example, he will use MDB2 for the area that he's working in, but sometimes he might like to see the whole module, which is maybe you can set up an MDB, like MDB7, which is showing you everything. So an administration or a project manager, etc., may be interested more of the whole project than just a common MDB2. All right, so that is an MDB. So every database inside an MDB will again be inside the other MDB. So when you write to one, you're writing for all the MDB to access. Okay, so that is something very unique about this system. All right. Okay, and lastly, you have various modules. Okay, and the modules are there to help you to do different things in your E3D project. Okay, so this is all I have to say. Any questions? Okay. So later on, I will promise you some of your questions. I will come back to answer. Those that I cannot answer will go to the end of the project when the, at the end of the section. Okay. So next topic that we want to is to do the 3D modeling. Okay. So we are going to do 3D modeling, and let's start. Okay. So the first thing that we do, let's go into the monitor module. All right. Because we just show you how to switch between module. All right. Okay. I'm having multi-screen. So sometimes you see that I'm actually, so just now my MDB I've changed to all. Let's go back to our A demo. All right. Okay. So then I go back to the model module, which is the 3D modeling module. All right. Okay. So it's still loading up. Interesting questions that I happen to hear this like for the past 35 years, this question about converting PDMS databases, PDMS project do not need to be converted to E3D. PDMS 12.1 SP5 onwards can be used directly in E3D. But some of the E3D interface will not be able to use some of the advanced things that E3D can do. You can't do it when you have the old databases because they don't have those elements needed. All right. So this is for PDMS. PDS, never heard of them for the last 20 years. So I don't know whether is there still a need to actually convert them. But definitely you need other tools to convert. All right. You need other tools to convert that is not provided by AVEVA at the moment. All right. Okay. So let's come to our section proper. Okay, so to create, so what I'm going to do, okay, before I actually, what do you call it? Talk, produce this one. So I have actually created something like this. So what I'm going to show you now is to show you how I create equipment, structures, piping, everything within an hour. Okay, so we are going to do that very quickly. So let's 3D view, remove. Okay, so let's go to the site and we go to general. Let's create a site and call this the real. Okay, let's call this the real seminar. Okay, okay. Oops, sorry. I actually, just now what I did was that I set the auto naming because it's the very top element. It doesn't know how to auto name. So now everything in E3D is put into a site and a zone. So a site is nothing just like it's like a folder in your Windows system where you can put things into different folders. But at the same time, each folder it had actually got a properties. So the important properties of every site element is the position and the orientation. So for example, if you are doing a project with, let's say, 3 offshore platforms, so the site may be shifted to the correct position in reference to other in your reference 000. So if you put all the 3 sites together at 000, every time you do your design, it will all be stacked together. So, but if you got 3 different platforms, you can put it at 3 different site location by setting the different positions and the different orientation so that everybody works as though like they are within their own platform. They don't work as though like they have to put in some very big values, etc. All right. So this is something about this site. Okay. So within the site, you can have zones. All right. You can have zones. So I can click on zone. Okay. Just now the error that you get because I have auto name on and it's the very top element. It doesn't know what else to do. All right. So let's say we want to create an equipment zone. So you say it's okay. And this, based on some conventions that I put, it will actually form out the zone itself. So the first zone that I created is equipment. Okay, I feel a structure zone, let's say a steel work zone, and then we create another zone for piping. All right. So, okay, so we create 3 zones. So again, you can see all this zone has got its position and orientation. All right. And you can put description, functions, and other information into this zone. So unlike your folder has got no metadata, but this one has got metadata, which you can use to filter for your, let's say, for your reports or something else. All right. Okay. So this is something that you should be aware of. So this is quite straightforward. Okay, so let's start off with, so there are many applications. So if you are a structure guy, so you use the structure application. All right. So E3D doesn't stop. Everybody uses the same interface, except that when he wants to create a structure, he can use the structure application which has got more tools that is in line with the structure application. All right. So we can't say that an equipment guy doesn't do structures because an equipment guy may need to do an equipment foundation build of structure. So therefore, we will have structures, application, equipment application for everybody to use. But where it can store this information is dependent on which team you are in. All right. Okay, so this is something quite important. All right, so the first thing that we do is that, okay, we choose the American standard and we choose the shape that we want. So this is the standard catalog that we have. So we choose a 14 HP sections. And we can also see what is the reference line. So everything that model will be based on the C-top, all right? A C-top module, all right? So with this in mind, let's create a bottom skid very quickly. And how we can do that? We just click on the streak. And okay, sorry, it says no valid owner file. So because a structure have to put into a structure to say that this is a STL area, and then you click into a framework. Okay, and this is okay, this is just a support framework. Okay, we can do something. So this is the base that we want to create. All right. So we click on the streak structure. Okay, so it says where is your start point. So you can see that the red color is east and west is RGB. Yeah. So green is X and Y, and B is up and down. So for this case, what we want to start is, let's say we want something okay, from the east, we have, let's say, we have minus 2000, okay, and then in the north, okay, in the north direction, we have, let's say, 2000, and then the up is 0. So that is our start point. And then, so we go the other side and say 2000 minus 2000, and then, so as you see, when I tap the system sort of like give you to the thing. Okay, so if you tap, I think I just now I hit a wrong key, I think. So sorry, one more time, because just now I hit something wrongly. Okay, so I just aborted my thing. Okay, let's start again. So you can see it's the absolute start point is so it's actually on the east is minus 2000, and on the north is 2000, and up is 2000. So let's start our first point, and then our second point is 2000, is minus 2000 again. Okay, and north is, okay, sorry, actually you can see that this is a relative, so therefore I can change to absolute if I want to, or I can change back to relative. All right, so relative, basically what I need to do is to just go to the south by 4000. All right, so I just click enter, and that creates my beam. All right, so with this first beam that I have, what it creates is that it upgrades the information in the database. So with this first beam that I have, what I can do a copy offset. So I say I want to create another beam on the other side. So this is X direction. So it's X direction 4000. All right. So apply. So that is the second beam that I want to do. So let's say I find that this beam is not the correct length that I need. So I can just click on both of them. Okay, and just double click on them. And then you just say here, you want to specify extension. Let's say, so now it's 4000 in length. So let's say we want to make it 10 meters. So we add in the 10 meters here, and then click on this portion, go in by another 3000. So now the items are now 10 meters. So don't take my word for it. So if you go to sections, you do display dimension, you can see that is 10 meters. All right. So far, so good. Okay, so right now, what I'm going to do, I'm going to change this to the, let's say, the left top, and I create a beam that is from this point. Okay, so this is where you can put your start point as the middle of here. And then, okay, so left top is maybe not the good one to do. So let's do it from the other side. Okay, so I just change it because I want it to end right there. So I go to the other side, and then I just go to the center point. So that create my first beam, and then I press again, I can create my second beam. All right. So we have created the two sections, and now we can create some beams in the center. We just say use our copy offset again. So this times I need 3 copies, and basically it's in the minus Y direction. So it's actually minus Actually, this 10 meters, so I need 3 copies, so minus 2,000. Huh? All right, so if I apply, no, so I short 1 copy, so do 4 copies, apply, yes. So this allows create my framework very quickly. All right, so now what do I need to do? I can, if you want to be the system to be logically smart, you can give it some logic, what is being connected to. So for example, I can use the connect button and says, okay, this section here, and I want to connect all these ends here. All right, all these ends that you see here, all the end that you see here, this end here, this end here, and it's all connected. Okay, and we do a connect again, and we select this side, and we want to connect this end, this end, this end, this end, this end, and this end. So then finish, so that's all connected. So what does connect helps me to do? All right, so if I click on this item and I say move, okay, what I want to do is move by 500 in the west direction. Oh, sorry, I have to change to displacement because I just want to move 500 in the west direction. So if you sort of like get here, you can see that all the connected beams will follow. So if you go to the other side, you do the same and say right click, okay, move. Okay, so for the start, you can do all the pure AutoCAD where you have a base point and a displacement point. But for this case, we are just interested to do a displacement. So you just say that this time you want to have 500 in the east direction, 0, 0, okay, and then you just move and everything will follow. So this is how you can create a simple beam. So with this, you can also create a, okay, so let's create some plates. So you have a 12 mm plate, and let's say you can just create a panel between 2 items here. So we can go here. Okay, you can do a shift right, and you can see I can choose different things. All right, so for example, you are interested to choose endpoint. So go to the first point, and then you go to the other side here. Okay, so this create the panel across the top of your beam. All right, so that's the first thing you can do. And let's say I'm going to create a platform right at the end here. All right, so what can I do? So I can create another framework. So I can create another framework, and then this time is okay, because I only got one choice, so I got no choice actually. One choice is no choice. So let's create another same type of beam. Let's say create straight. Okay, so let's say use the start point, and we choose. Okay, so when I go into this, I want to make sure that I select the correct point. So when I select this, and then I can say 0, 0, and then you got, let's say 2,500. All right, so this create, okay. So maybe what I choose is the wrong one. So what I can do, instead of L top, I change it to R top. So is the, okay, if it's not left, it's right lah. So I don't have to remember a lot of things. So if that's the case, then what we can do a offset again, copy offset. And then this time, okay, so instead of in the, instead of the Y direction, it is actually in the X direction. So for example, we know is, okay, so sorry, that's not a good idea. So let me do this. I click on this item and I say context, I say move. Okay, so the move command, what you need to do is to go down and you can say copy. Okay, so where is the base point? So the base point is, let's say we want to move it in the east-west direction. So we just make sure that the north and up is locked. So with the north and up is locked, that means we only can go by the Okay, so let's select the, beg your pardon, sorry, made mistake there. Okay, so let's say move. All right, we push it down. I'm hitting the down arrow key and I say copy. So where's the base point? So basically I want the base point to be here. All right, so I can choose, in fact, the center of this portion is also fine. Or I can choose, I think the best is to choose the, shift this and choose the endpoint. Okay, and then when we move, we have to make sure that we don't drift in the north and the up direction. And we just go basically to the endpoint here. Okay, so that creates the two sections. And now if you take this section or this section, you can say copy offset. And this time we want it to be Y 3000, let's say. So apply, yes. And then you go to this one and you say current element and it's Y 3000 again. Yes, okay. So that allows me to quickly do my platform on top, and then I can continue my sessions and I do a simple sections of straight again. And this time I just take this center to this center. Oh, okay, what happened is that I'm actually left top. I want the center top. All right. So let's say I put center top and I create. Okay, this time I will use, because I don't want to use my space bar all the time. So I just go to repeat. So just go there, choose what you need, go to here, choose what you need, and then go to here. Okay, and then you can go to here, this portion, go to this side. Okay, and then go to here. Okay, and then go to, okay, so we have created the top. And now with the top created, we can do our place again and create a panel between 2 points. So we have the end here and the second point is just here. Have I selected the wrong end? Okay, let's do it one more time. So panel 2 points. Okay, and then we go to this other end. All right, so this create the platform that we want. All right, so now let's finish the structure very quickly, or yeah, let's finish the structure very quickly with some stairs and handles real. Okay, so let's create a run ladder. Okay, so let's put a run ladder to be right here. Okay, so create a ladder. So we can choose some standard default, ISO defaults. So this gives you the spacing, etc. So these are the information that you have. And then you say, okay, where's the top exit? So just put it somewhere in the center and then pick the bottom exit. Okay, so you can say, okay. So this is the thing. So it gives you a highlight here. And what you can do, you can modify the positions as well, because you can see that this is too much inside. So for example, what you need is something that is more soft. So maybe offset by, let's say 250 to the south. So apply, so that is more or less where we want the stuff. Okay, so with that in mind, what we can do, we can just say create build run ladder. All right, so this is how the run ladder can be built. Okay, so from now we can do a handrail around it. Okay, so let's start the handrail command and choose the standards. And then, okay, we can name it, give it some names, set up the height, etc. Okay, I'm going to take the default for this demonstration. And I will select 2 points first. So I select this endpoint. Okay, and then, Okay. Okay, and let me one more time. Click here again. Okay, first point. Okay, so you can see the first 2 points, can't you? So right now, we have an issue is because we need to start from the edge of this handrail. So what I can do, I click on this and I say select this point and move it to come to here. All right. So what I can do, I just go to here. Okay, I just pick the end of this. So now this point come to here. So if you look at this and then you say, all right, change the current point to here again. Pick root point to make current. Okay. Okay, so when you go back there, and now you can add the rest of the points. All right, one. Oh, okay. So let's redo this again. Sorry, my mistake. I think I must have screwed something up. All right, let's go back here again. Okay, I need to do the first 2 points on the platform because I want the handrail to be around the platform, but there's a gap here. So that was why I had to. So I start by selecting the first point here, and then selecting the second point here. So this is the current point that we see. Then I want to move this point, okay, to this point here. So this will actually cause it to here. And basically, I want to select my point to continue. So I select this point. Okay, and then I add this point at the end. Okay, and then I have to select my point again to point number 3. And then I will finish up the routing. All right. Okay, and then I go to the last point here. Okay, and then we say build handrail. So that is the handrail done nicely for you. Okay, so that's it about structure. I think let's move on to the next one, which is let's put in some equipment, and then after that we will route the pipe. Okay, if you have any questions, just put your questions in the chat so that we can continue to help you later on. All right. Okay, let's go to equipment now. Okay, so for this demonstration, I'm one person, so I put wherever I want it. So I put into a zone for the equipment, and I'll start off with a standard equipment. All right. So these standard equipment are created by your administrator to actually allow you to change properties that you can use. So for example, if I do let's say P-SS001, okay, and then we can choose the different standard equipment or standard equipment or why standard equipment or advanced equipment. All right, so you have different like pumps here. Okay, let's say you want whatever pump that you want. Okay, let's choose. Okay, so we want to do a tangent one or this one. Let's do a tangent one. Okay, something like this, right? Okay, so let's do this, and then we say apply. So it says position the thing. So I don't actually care where it's positioned, but because if you look at the plot file, okay, you can see that the center of the equipment is here. So when I say apply, it will expect me to tell him where the center of equipment is. So that's why it is there. All right. So with this in mind, what we need to do, first we have to rotate the equipment. So just click on this, and then you can say rotate by 270. Okay. So that is done now. So this is correct place. Now we lift it up to the top of the platform. So what do we use? We use the move command. So you can see that we are using exactly. So if I put the base point here, okay, so let's put the base point at the bottom. And then instead of So the second point, we want to move it up. So we have 0, 0, and then we select something that is on top of this one. So we can, okay, so we just go to the click here, and then we select, okay, that place is quite cluttered, so we can just select something at the end here. All right, so now you can see that the equipment is shifted to the correct place. And now what we can do, we can say, so we can say move, and now we can use the displacement mode. All right, so we can say, all right, we want to move, we want to move the east by, let's say, 2000, and the north by -2000. Okay, and the up as 0. Okay, so with this in mind, it will get to the some place that we need to position the equipment. All right, so with that, let's create another equipment. So for this equipment, okay, what we can do, we can modify the two nozzles that are inside the equipment. All right, so we got nozzle 1 here, and we can say equipment and then modified nozzle. Okay, so the nozzles are spec driven. Okay, so we can choose that. Okay, this one looks like the correct nozzle. Okay, so if I select the nozzle again, let's select the other nozzle. Okay, this is the 2-inch and the other one is the 4-inch. Okay, so that's fine. Okay, so we are good. Okay, so right now, let's say we want to create another piece of equipment, and this time we want to put on top of the platform. So we say equipment standard. All right, so if you say electrical equipment, general pumps, advanced equipment, and let's take a look at vessel. So let's say you look at the properties of this vessel. All right, you can see the property allow you to choose the specs for the nozzle, which unfortunately I didn't bother to actually change. So you can make it a choice for the user. So which unfortunately I didn't do it. So with this, let's say we call this B-SS001. All right. Okay, so let's apply and position the equipment. This time position at the, where shall we put it? Let's say we put it in the intersection. Okay, let's say we put at the center of this one. Okay, so, okay, so we have put in the center there based on the center point, and we can choose this again. We can rotate. Okay, 270. Okay, and then we can do a move. Okay, and we can start with down, and we call it displacement, and we can go east. We can go east a little bit to the top, 500, and we can go north about 2000 and up as 0. Okay, so that moves there a bit. So maybe we still not going half. Let's go move some more. So we can go D displacement, and this time we want to be more east. Let's say another 1000 to the east. All right, so we have our equipment aligned and ready to go. Okay, so before we do that, let's take a look at this equipment and let's modify a nozzle. So let's say we modify a nozzle again. So I say, okay, I say select nozzle. I want to, so I'm going to route a pipe between this pump and this nozzle, of course. Okay, don't ask me what's the direction. So this is we use an enzyme nozzle. Of course, we have to use a compatible nozzle. And then we do a 300 pound, and this one will be a 4-inch, okay, etc. And then so this item has been change. All right, is it 4-inch? Yeah. Oh, sorry. Let's change it to 4-inch. All right. Okay, so that's been done now. So now the two nozzles are ready. We are ready to what do you call that? Route a pipe between the two. All right. Okay, so okay, we are about on time now. So let's route a pipe between the two. So we go to the piping zone. Okay, so we say change our application to piping. All right. So change our application to piping. Okay. First is to create a new pipe. So let's call this P-SS001. All right. And then we choose the piping class that you want to use. For this case, we are using the PSS01. Oh, because my pump is called PSS01. Okay. So let's say call EISS01 and choose a 300 pound. And you can put in this information. So for example, your fluid reference, if you are interested in the weight with fluid, you can put a fluid reference and the system will give you a estimator of weight of the pipe with the fluid. All right. Okay, so we apply here. Okay, so right now, branch head, let's say we want to go from this point to this point here, all right? So we go to branch head, we say where is this connected to? So it's connected to there. So you can see that now the head is there. So the guy knows that it is what do you call that? It is a flange. So it just gives me the first two components. Then we go to the branch tier. All right, and then we select the component here. All right. Okay, so with this in mind, you can use automatic routing without any settings if you want to. So if you do let me just do a save work. Okay, every time you save work, you can put a comment as to what you did. And you can, if you don't unclaim, nobody else can take over your job, but you can continue to work on the same items that you have used before. So just do a save work. So we can click on auto route branch. So yes, you see that it's warning me I have a crowd, point crowd. So you can see, oh, okay, quite nice, isn't it? So work is done. Okay, but okay, let me show you something else if it's not so simple. Let's say we do something else. We just want to go here, come down to the bottom here and end up with here. All right. So how can we do this? Okay. So what we need to do is to go to the, okay. So what we need to go down is to go to the create components. Okay. So let's create component. Okay. So what we want to do is to go to the flange here. Can you see when I snap on the flange here? It gives you this arrow that we are continue to route from this arrow. So what I can do, I can say, okay, I want to do a long radius elbow here. So I just put elbow, and I want to also create one more long radius elbow. And this time, I want to direct it down. Okay, and I want the distance between the two things to be at, let's say, 1,500. Or too much, maybe 1,000. Okay, so you can be stacking things together and route along the way. Okay, so another way to do this, let's say we throw away this component editor, is to do now we do something better than what we did just now. Double click on the thing, and we basically go to quick pipe routing. Okay, let's go down to here. And then I can say, okay, I go to here, okay, and basically I go to here and then go to here. And then I can say, complete the routing for me. So this is how the system can be used for routing a pipe. Okay, so now that we have done this, let's save work. Okay, what we can do now is to do a crash check. So one of the things that is very good with E3D is that after doing something, you can check whether you have any issues or not. So so what we can do, we can go to the crash checker. Okay, it just opened up on my second screen. Okay, okay, I just moved the crash checker to be here. Okay, so right now, because I have a lot of things all over the place, so I go to my extrude obstruction and I say remove all. And then I choose that I'm only interested in what's in this site to be checked against. Then I go to my pipe and I say check CE. All right. Okay. So it has found a crash. Okay. It has found a crash. So it's and it has found, oh, okay, you can see that it has found a crash with the section as well as the plate here. Can you see that? Okay, so let's resolve these crashes. So how we resolve these crashes? So so we need to move a bit to the left, right? So we can create this, and then we just say okay, and I say we can say enter value. Okay, we can say is minus 200. Okay, do a preview of it. Okay, so that's it. So that's done now, and we go back to our crasher. Okay, where is that window now? Okay, I don't know where is my window. Okay, so okay, let me close this and then call out my crash window again. Okay, so right now you can see that I only have one crash now. Okay, I only have one crash now, which is on the platform itself. So how come my crashes? Did I choose auto crash or something like that? Okay, so I can go here and say check CE. Okay, and then it just checks, and then it should give me my crash. My crash window seems to have what do you call that? So right now there's only crash with this item here. So what we need to do, we need to do a penetration. So we go to the structures, and then we can go to structures and we can create penetration. Okay, so we go to plates, and we can create go to sections. Sorry, where is the penetration? Okay, so we go to plates and create not negative, but we should have a connection review. This is the plate. Or it's actually in the piping. Okay, so we have penetration. We have, okay, so we have, so this is the piping one. We have the possibility to create a penetration, all right? Oh, okay, this is the more difficult create penetration, which I haven't used before. Or, okay, so big penetration item, this is the one in which the hole is created. Big, all right, okay, so big penetration item, which is this guy, and the big, this one, and the penetrating item is this guy. So, okay, and it will supposed to create a penetration there, all right? So you have a circular hole, and then you have minimum clearance. Let's say you want it to be 10 mm or whatever amount that you want, okay? And this create the penetrations for you, all right? So this is how you can create a penetration. Okay, so this is the modeling that we can do. We can do paper tray modeling, structures modeling, etc. So far, any questions? Any questions? Is it difficult or is it easy? Can I ask you a question? Is this difficult to understand or easy to understand? Hello? Okay. Okay. Okay, so easy to understand, go ahead. All right, thank you very much. Okay, so actually, right now, we have done the modeling. So we have done all the modeling, and then we like to take a break. Can we take a 10 minutes break and be back by 3 o'clock? And then we continue the isometric and reports. Okay, so one question now. Okay, I think okay, we finish any questions until 3 o'clock, and then for this earlier lecture, and then we will try to then go for a 10 minutes break, and then we come back, we do the other stuff. Okay, is it possible to detect the crashes with bolts, nuts, support socket? It is possible. Okay, it is possible to do that, but the thing is that you must model the actual whether it's a cylinder, etc., in your catalog. Okay, but when you model it in the catalog, you can make it don't show in your detail view, but it will actually check for crashes. So this item, because they are hard items, we suggest that you use a hard method so that you will come out with a hard crash, okay, rather than a soft crash. Okay, so that is possible. But you have to put in the actual volume that is put into it. All right. Okay, how to model a mitre fitting. So mitre fitting can be set up in the catalog with a special attribute for the band to tell you what is how you actually, whether it's a 3D, 2D, or 4D, or whatever information that you need, so that it will be modeled as a mitre rather than a curve. So it uses a band. All right. Okay, so just now when we wrote, it uses, these are elbows, these are not band. Okay, these are elbows. So if you want to use a mitre, you use a band to do that. Okay. The mitre can be treated as individual fitting. A band can be treated as you can put your band material as a pipe or a piece of mitre, a piece of component. It is possible. So when you actually have a mitre band, it can be, but when you have a band, it can be shown as a straight pipe. It will give you the pipe name, it will give you the pipe component, but it doesn't give you as a band. But you also can make it as a band if you want to. Yes, so mitre fitting will be actually output as a pipe. Sorry, mitre fitting using a band will be output as a pipe, not a band. All right. In your isometrics. Good question. And anybody? Okay, mitre fitting is used quite normally in shipbuilding. Shipbuilding uses band rather than what do you call it? Rather than elbows. Okay. Okay. On the subject of the band, E3D allow you to configure your fabrication machine as well. And the fabrication machine is used for pipe bending. So by using the fabrication machine, you can check whether is it possible to actually create the bend. I mean, is it possible to bend the band based on what you have? All right. Okay, let me go through some. Okay, so the thing is, can we use or convert PDMS or PDS database in E3D? PDMS don't have to convert. You can open in E3D. Of course, not the old PDMS version, but the PDMS 12.1 SP5 version. You can open in E3D and use as per normal. All right. So you don't have to, you can use the project in E3D. At one time, people can use both PDMS and E3D together in the same project. All right. Okay. Fahmi, does that answer your question? Okay, so that's for your information. Okay, why I'm getting this, is it somebody just said something? Okay. So, okay, the catalog or database default is still, if we use another type of specification, can we convert our current database to E3D? The catalog, the catalog database contain structure, contain cable trace, contain HVAC, contains everything. So it is not necessarily only steel. So when you say use another type of specification, what do you mean by using another type of specification? Hisham Mustafa, what do you mean by using another type of specification? Hello? I'm actually answering a question. It says, do we need to convert our current database to E3D format? I don't, so when you say another type of specification, what do you mean? Okay. Hisham? Okay, Hisham, when you come back, you can maybe elaborate more if you want to have your answers. Okay, detect only structure crash. Just now I showed you, you can restrict what can be crash check, etc. All right. Okay, so I think we've answered the questions and we finished 5 minutes ahead of the break time. Okay, maybe perhaps we have a break and then come back at 3:10 and then we continue to do the reports and deliverables. Is it okay, everybody? Okay, see you later. Hello, everybody. Are we ready to start? Yes? Hello, can we start now? Hello, can we start now? Okay, very good. Thanks for steer with me today. So now let's say we continue from where we left off. So let's say we go back to the branch here and we say we go into piping, create components. All right. So first thing I'm going to show you is to do an analysis. Just now you saw the interference checking. So now let's say we want to do an analysis. All right. So let's go into a valve. Let's create a valve. Okay, let's create a group valve. Okay. And then we try to put it somewhere here in the middle here. Okay, so I think it picks up the wrong thing. So let me do it one more time. Okay, so I can just do a Control Z, and it will go back to where it is. Okay, so let's say we want to create a valve. So we go to valve, we go to group valve, and then we sort of like, well, we can say, okay, we want to create components. So let's say we go to here, and then we create a component, and it says, so we can put it at the, let's say we say at the center of this item here. All right, so we have created a valve. Okay, so and it asks well what type of flanges we need. We choose the well-net flange, and then we say done. Okay, so that creates a valve. All right. So with this valve, what we can do is that we can double click on here, and of course we can move the valve. Okay, we can move the valve to the end, etc. All right. Okay, so why I want to show this valve, because if let's say you have forgotten to put a gasket in between the flange and the valve. So what happened is that if you are doing your, just somebody asked about FRP piping, you want to have a connection compatibility. So let's say somebody decided that if you forgotten a gasket, and then we go back to the branch and you do a data consistency check. Okay, and you say check CE. So it can tell you that the flange, this flange here, okay, this flange here, and the valve is the connection type is not compatible. Can you see that? So basically, this connection type is just a alphabet to say that, okay, this is called a flange, and it has to connect to a gasket. A flange cannot connect to a flange. So every connection has a connection type. All right. So because of that, so let's undo what I deleted. And now the gasket is back here. We go back to the branch again, and then we do a check again. So right now, the only problem that we have is the attachment to this thing here, because there's an attachment and it seems like it's not a compatibility type. So but that's okay, because we know that there is an attachment which it should not check. Okay, so this consistency check can be done immediately after you have routed a pipe, or you can do it as a batch, so that all the pipes that you have routed, you can check for this to make sure that there's no problem before you actually go and produce your isometric. So you saw two analyses, which is to use the data consistency check and to also do the crash checking. All right. So with that in mind, what else can you do? Of course, you can do reports. That's without to say that's something that we can do. So if we go to, where is my, let's say tools, let's say we do, okay, so we run a report, right? Okay, so for example, we say, what we want to run. We want to say, pipe this or something like that. Okay, so okay, so sorry, we have to just go back to the pipe. Okay, so let's run some reports, all right? So let's say we look in product or look in project. Okay, so everything in E3D, there's a user. That means those information are only valid for the users. Project means information valid to the project, and product means that it's a global thing that everybody should get the information. All right. So if I go to pipe detail MTO, okay, so this is a thing and says you just run it. Okay, so this will create the MTO for the pipe. Okay, so you can see the, what do you call that? It actually went and take all sorts of different material. I don't know why it's not a pipe MTO. Actually, it is a all the material in the whole project you can actually see in this MTO. There are 60 pages of MTO. So I'm not sure what are the MTO available, but these are some of the reports that you can have. Okay, so this is a okay. So if you do a simple report like this guy here, you can put it to a screen, or you want to put it. So for this case, you can have branch member, and then you have columns. What columns you have? You have got type. Then you have got DTXR or something like this. So you just run, and this will show you the report. So I can't remember how you can get quantity out, but these are the information that you have of all the MTO. So there's many ways to do MTO, all right? So this is one of the ways, okay? So we have done MTO. So you can do any reports, anything that you want from here. So for example, if you want the report of equipment and position, so what you can do, you can even do something like this. So if you go into your home, you can go for search tools. Okay, so what you can do, you can just say equipment, okay, and then do a search, and then you can see there are two pieces of equipment, unfortunately. So you can see that if you put it out, so you can say that, okay, these are the two equipments that are there, and then you can change the column to say, okay, what else do you want? You want the position of the equipment, so you add a column, say, call it position. Okay, and then then you can see the position of the equipment. So you can do lots of different ways to collect reports, all right? And basically, what you can do with this thing is that you can search for the equipment, and then you can give it some, say, maybe description of this equipment is in seminar area. All right. So we do something like this simple. We just apply it. And now if we put a column there, you add another column called description. And you can see that all the description can be set up this way. So yeah, you can, okay, so the MTO can be run for individual line or a whole MDB. It's just that I'm not sure the reports have what it has, but later on in the Q&A, I'll show you some of the reports that we created for cable trace. All right, so the cable trace report can be replicated in the piping report also. Okay, so we have like, you can do a MTO and you can select certain things, but now we don't have the correct cable trace, so we cannot generate the MTO. Okay. Okay, so now that we done this, okay, let's now look at isometrics, shall we? Okay, let's move on to isometrics. So if we go to modules, we go to isometrics, all right? Okay, so we are going to run an isometric. Okay, so the MTO can be extracted in isodraft module or in design module. With the isodraft modules, it can give you the bolting information and other information. So the reports from the isodraft module will be what you get in the isometrics. Okay, the reason why I put the valve there is to show you something in the isodraft module, all right? Okay. So in our seminar thing, so if we go to real seminar and we go to piping, we only create one pipe. You can go into do a standard isometrics, and then you can use a basic metric. And this will create a combined ISO of erection and fabrication ISO. All right, so that's how you can create a isometric. Okay, it is creating the isometric in PDF. So it gives you the isometric in PDF. So you can see all the, so F3, G5, and B6 is actually F3 French. Okay, so just a minute. F3 French, and then B5 is bolts 5, and G4 is gasket 4. So you can see that you have 4 quantities, etc. So this is one type of metric, and you can see that because I put attachment here, you can see that's where the penetration is. All right. Okay, so that is one isometric that you can create. Okay, so now what we can do is that, for example, you want a spool isometric. So we go into here. Let's say we go options and we create a new option. So you want a spool isometric, right? So what we can do, let's say we take the isometrics from the basic metric file, okay? And the first thing that you can go to is the administration. So this is the output where you can output it to PDF, you can output to DXF, you can output to anything that you like. So for this case, we are output to PDF. And if you do not want to, you can output to the traditional PDMS output. All right. Okay, so this is one of the things that you can set up. And if you want to meet the isometric searchable, you will have to use true type fonts. Then you can't select PDMS output, you have to select the other output. All right. Okay, so the second thing is that if you want this to be a spool isometric, you just change this to a isometric type spool. That's all that you need to. Okay, and then the last one that you can need is that just now you notice that the well numbers are not shown. The well numberings are not shown. So you can go to numbering and say, show the well numbers if you want to. Okay, so let's dismiss that and go back to the same pipe, and we do a standard isometrics, but this time we choose the spool that we actually do. So now it doesn't generate PDF, so it will be slightly faster, so it will be all displayed within the isodraft model. Okay. So you can see now the isometric has got 2 ISO. So you can see the first one is from the top of the vessel and it stops somewhere there before the start of the French stop there, and the gasket and the valve will be shipped as erection material, and the material list will be updated accordingly. So you can see there are only 2 flanges here because there's only 2 flanges here. Then if you take a look at this second one, you can see the second portion with the isometrics, the spool being split to the correct requirements. Okay, so this is, so the isometric is customizable, and of course, you can put what you do into a batch file that you can generate like 1,000 ISOs in, not 1,000 ISOs. So far, probably I can do about, I can run the batch file to generate about 100 ISOs. All right, so that people can got time to check. Okay, so this is something by piping ISOs. And of course, in the piping isometrics, just now the options file that you see here, you can also output the material file. So if you go there and look at material list, okay, you can choose what to output and you can create a material list file. Okay, so this will output the output as a text file. You can put the directory and then you can have the MATL. Now this file, you need an interpreter to check this file and convert it to whatever that you need. All right, so this file is not a normal text file, but it's actually convertible. All right, okay, so this is isometric. Okay, before I get out of ISO draft, any questions? Any questions? Seems too easy. Okay. Okay, so how to unmute? Oh, sorry, you want me to, I can say, how to unmute? I thought just now. Okay, you want to show cutting list. Okay, just a minute. I don't know how, just now, ask all to unmute. Can you unmute now?
Okay, I'm unmute already.
Okay.
Can you hear me?
Yeah,
So,
you.
This I don't know, this the drawings can fabric is for fabrication drawings, or there could be another level of drawing of short fabrication drawings. I'm looking at this spool isometric, still isometric, basic isometric.
Is fabrication
the-
isometric. Is fabrication isometric.
You see, for our fabrication, our people will need to know each pipe cut length.
Okay, yeah, that's why somebody asked where's the cut length. So basically, if you go into here and somewhere inside here, you have the cut length table. So if you go into material list and then cutting list, okay, number across sheets or number per sheets, etc. And then you just say okay, and then but cut rules, okay, cutting list. I can't remember exactly what it is. So this is a cutting list. So when you have that, then you generate the same ISO again.
Okay, there's all options. Okay.
Yeah, so you can do a spool ISO again, and you will see something at the thing. All right, extra length. Extra cutting length is the field feet allowance. Okay, you can put field feet allowance at the end of the whatever that you want, or you can define them differently for everyone. Okay. Okay, so you can see now the cutting list is there. All right. So, and then you ask whether possible to add some more items to the spool drawing. Yes, of course. You have to set it in the attribute called MTOL. So additional information like you want bolts, not bolts, but you want anything else that is not standard, you can put it there. Okay, it is possible.
Okay. Okay. Another question. I don't. Okay. Here is okay. Good to have all the cutting length. But for steel pipe, I'm not sure anyone interested request to have the end configuration. For example, here you have a bevel end. You may have one piece of pipe. You have one end is a bevel end. The other end is a plain end for the socket weld.
Yeah. You can put that information in the cut length, but I can't remember exactly what is it that caused it to say it's a bevel end or a plain end or a whatever that it is. You can do that as well. You can
Okay,
do that.
that's one of the area probably in future we need to explore.
Mhm.
This is crucial, is important for our production.
Yep. Understand. It is possible, definitely is possible because I've done it before. Okay, but recent years I've not been into this here. So if you look at the material, sorry, not material list, but material material list, not material columns. Okay, so you have got M preparations here as well. Can you see M prep here? Okay, so with that in mind, then of course, if you do another piping ISO one more time, you can see the bevel end. Or I think both all these steel pipe have the same end preparation. Okay, so this is something. Okay, so all these isometric, the spool standards is actually just a file. Okay, which it can be stored with the project or stored company-wide or stored by the user. Okay, so so there you have it, the end preparation. All right. Okay, so we can put the end preparation. Okay, anything else? Okay, one more thing. If you use your spooler to control your isometrics, you have more flexibility with more information. Just for your information. Basically, a spooler element allows you to keep everything, what do you call that? We have to keep everything that is related to spooling application. All right. Okay, so right. So now we are touching on the thing. Somebody asked me, can you show us how to edit the item attribute? If we want to change the branch size, outlet type, dimension, or socket for socket, etc. So you have got so many things. Of course, it's possible, but you have to change it in a logical manner. Okay, so to change the branch size, you can. If let's say you have existing like you have a 4-inch pipe and you want to make it into an 8-inch, then you actually change the whole branch and it can automatically select the 8-inch components for you if you do it that way. Okay, the outlet type, you mean the T type, is it? What do you mean by outlet type? Okay, outlet type, dimension or socket, etc. All this is found in your catalog and specification. It has nothing to do with the design because the designer doesn't determine what you want to use. Okay. Okay, Hisham, you got my answers? Okay, so if we have time, we can show you. Okay, any more questions with isometrics? Okay, so if no question with isometrics, let's create some GA, shall we? Okay, so let's go into the draw module. Okay, no, don't want to keep the profile. So everything that you see here can be put into a script that is run overnight. So you can finish all your modeling. You get a script to check the modeling to make sure that it's correct. And then you can run everything overnight. And then any information you need, you can just, any errors you have, you can just change. And then after that, you can generate the drawings. So the drawings for isometrics is quite fast. Okay. So, okay, so right now I'm going into the draw module, which is to produce the 2D drawing. Okay, is to produce the 2D drawing. Okay. Okay, so this is this. So we have the Draw Explorer. So everything in E3D is talking about a database. A drawing is also described in a database. Okay, a drawing is also described in a database. Okay, so how do we generate a drawing for what we model? So if we go to the Model Explorer, remember our seminar information are all here. Can you see that? They are all here, right? So what we do is that when we go to Draw Explorer, we can say, okay, we can say create a new drawing. Okay, so what we want to create, so let's say we want to create a drawing and it's an A0 size drawing. Okay, so these are actually set up by an administrator with the correct frame, etc. for you to use. All right, so you say you're drawing and then you can say create. All right, so now where to create the drawing? So your drawing is, let's say we create a new registry here called seminar registry. Okay, so let's say we want to create in the seminar. Okay, so let's say we want to create in the seminar registry. So we say create, and this will create a sheet for us with nothing inside. So this is just a sheet of paper with nothing inside. So there are one views. You can set it up so that you have multiple views if you want to, or you can have one view. So you can just, let's say I move this view somewhere here, make it a bit smaller. Okay, so with this view in mind, now we can go into edit in 3D. Okay, so this is the 3D view now. Let's go into our Model Explorer and put our whole piping, etc. into the model. So this is the view. And basically we are looking at run down, but we don't want the thing to be this way. We want it to be, let's say, 90 degrees this way. Okay, maybe this is a better way. So the north is this direction. Otherwise, the north is that direction. And you can change the scale to the nearest. At now is 1.37. So let's do a 33.1. Okay, so if you are happy with this view, you can enter and then say finish. All right, so now it will generate the view. So if you click on the view now, okay, what you can do is that you can see that how the view is represented is dependent on your representation rule. So let's say I change it to basic depth representation, and I want a global hidden line. Okay, so that will hide those things that are below it. So the representation view will say, okay, everything that's below, that's hidden, the structure that's hidden, I want to show it in center line. The structure that are not hidden, I will show you full, but all the structure are hidden here. So that's why it's all in center line. Okay, so this is how you can create a view. Okay, so now with this in mind, let's say we want to create the elevation views on the right and left side, right? Okay, so what we can do, we can create a projection view. Okay, so I say I want to create a projection view from here. Okay, so if I go down, this will be the projection view looking from the below up onto my plan view. So I can say, okay, put it here. Okay, and then type finish, and the projection view will come up. And then let's say we create another projection view. Okay, and we use this view again. And this time, just put it to this side. And then we type here. And then we say finish. And of course, we can then click on the item and then just move the thing a little bit on the X, let's say minus 200. Okay, so I used to type so that we get exactly what we want. So, okay, so our view looking like this. So quite easy to do, right? So you can do any view, you can do section view, you can do detail view, whatever that you need. All right. So, if I say I want to create a detail view, I just click on detail view. Oh, okay, maybe what I do, I create a ISO view. All right. So let's say we want to create an ISO view. All right, so let's say if I go to quick view and I say select model explorer and sorry, okay, so select model explorer and then enter and then say first corner, second corner. All right, so when the view come up, again, you can here and you can say you want a ISO 2 or something like this. And then you can do the change the representation of basic. And then you can do a robot hidden line. So you can get an ISO view very quickly. Okay, so with the view set up, we can do some annotation. So what are the annotation we can do? We can do many types of annotation. So let's say we go to, let's say we want to annotate on this view. So we go to this view first. And then basically what we can do, let's say we want to have the equipment. Okay, let's don't do equipment tagging first. Let's do the, what do you call it? Let's do the dimensioning first. So I can go here and I do dimensioning. All right. So now with the first thing in mind, what we can do, you can also, okay, so you can just dimension from here. Okay, and then we go to the next one, which is what we want is this item here. Okay, and then you put it right here. And then you can continue to say, okay, I want to put this one. I want to go to end of this. And then lastly, I want to, this one a bit tricky to select. I want to go to the end of the platform. All right. So this gives me the dimensions that you see there. All right. Okay, and another thing, let's say you want to do another dimension here. Let's say you want it to take this edge here. You also can do something like this called position, and then you say before. So what you choose is what the dimension point before, because it's a rounded one. You can just pick this item, okay, and then you can choose where else you want to go to. Let's say I want to go to, okay, because I choose before, I have to go down. Okay, so I can just go down to somewhere here, and then I can put the dimension right there. Okay, and then I can just, oh, what did I do? Sorry, let's do it one more time. Okay, so I say here, I go to here, I choose type, change, sorry, I say position, and I want to choose something that's before. Okay, so I choose the first one, and then I choose the second one, and then I put my dimension here. Okay, and then I just, why is it my dimension cannot be seen? Okay, I must have selected something wrongly. Okay, so not so nice, this thing. So let's okay, if we cannot do it, then I don't know, is it because I selected wrongly or whatever? So let's try this one again. So if I go to here, and then I go to here, and then I say, okay, so now, so this is how you can do dimensions, all right? So the dimensions are intelligent dimensions, just for your information, because if we go to the Draw Explorer, you can see that if I click on the dimension here, this is the dimension, and you can see all the dimensions, and they have references to the 3D element that you are referencing to. All right, so they are not stupid dimensions, okay? Of course, we will come back here later on and check it out, okay? So let's do the annotation on this one, all right? So let's go to this guy here, and now let's do some annotation. So we can do annotation. Okay, so it asked me to select what kind of annotation I want. For example, you want a equipment level. Okay, so okay, so for this annotation, you can say specify attachment point. So we can attach to any point here. And then you can say, okay, so you can put your annotation where you want to put it. Okay. And then, okay, so the issue that I have is that I want to have a general annotation. So we can put it right here. Okay. And then you select the design element. Okay, so we say that we want to take information from the equipment. Okay, okay, I made a mistake just now. So, okay, so I put it here. Okay, and I can say I want the name of the item. Okay, so this is the intelligent text. So you can use all sorts of text for intelligent purposes. All right, so you can say, okay, so with this in mind, this is this one, we can just remove this annotation that we do not need. Yes, and then we go to here, this guy here, this annotation here, and we put off the visibility. So you can see the annotation. So we can annotate a lot of things inside our 3D model. So we can do basically all these inside E3D. Of course, you can add your own overlays, which is some details that is common. You can put it inside there, etc. Okay, so this is how you can create your 2D drawing. So the important thing about this 2D drawing is that if I select this item, you can see that it goes to my 3D database. So they are all still working in the same environment. So any questions so far? Okay, what I'm going to do now, I'm going to go into E3D and move this. So everybody remember this is 2000. So I'm going to move this by 500 and then see what is going to happen. All right. Okay, so if I go into project modules, I go to model again. I save the changes, I go to model. Okay, so while we are changing, this is a good time for anybody with any questions. Can you unmute yourself? You are, okay, so I don't know, every time I ask all to unmute, then, okay. So you have any questions? Okay, okay, some questions that we can answer while we are in design. Okay, I could have saved my view just now, and I go in, I do not have to put things into my drawings again. It's also possible if you save the information before coming in. All right, so let's take a look at our thing again, our equipment, and then let's take a look at our piping. Okay, this is what we have, right? Correct. So let's say we take this piece of equipment and I home and I do a copy offset. Okay, so I can go here and I say I want to be minus 1500. Okay, apply. Okay, so this is good enough for me. Okay, of course, then you can change this as rename it as to P-SS002. Okay, so this pump SS02. And basically you want to connect these two up. So how can we do it? we go back to this guy here, go back to this French here, and we go to our piping, and we go into piping, and we say create component. So what we want to do is to create a T and then connect the two up together, all right? Okay, so we choose a T. So now it's a 4-inch ball. So what we want is that we want a 4-inch T, and then you want to put it after the component, all right? So you can just click here and then move it so that, oh, okay, so you can change the modify, and then you can say that this one will face the west, and then you say that you want to be, let's say 300, I just shift it away a bit so that I can use this item, because they stick together, the software thought that it will stick together. Okay, so okay, so if you sort of like move this around, so if you go to here, you can say align with feature. Okay, so we align these two together. Then what we do, we go back to our pipe. Okay, and say modified pipe, and we basically create another branch. Okay, so we are going to create another branch. Okay, so we create a new branch, and then we will put the, okay, we will put the branch head, just select the T, and then the branch tier, just select the nozzle. Okay, so that is how we can create a additional item. All right. Okay, so this is one of the things that we can do here. So let's go back to this vessel here, and we say 3D, and I say, let's change the name, because just now so from SS, we put an A behind. Okay, so we can make changes here, and we can go back to our drawings, and then we can just update drawings. Okay, but before we go back to the drawing, let's save here first. Okay, so for example, if I take this pipe, and then what I'm going to do, I'm going to say copy offset. Okay, I want to offset in the X direction. Okay, because our friend want to check whether if I change like from 4 mm, from 4 inches to 8 inches, how do I do that, right? So let's say we move it to, let's say we put it somewhere far away. Okay, apply. Okay, yes. So right now we are at this thing here, and we go to our piping, and we can say modify pipe. Okay, so it's current pipe. Then you can decide that what you want to do. You just select all or something like this. Then you can say, how do I change the size? Okay, so modify ball. Okay, so instead of 4 inch, you change to 8 inch. Apply. Okay, so this will find the relevant components at the 8 inch level, and then you just apply. Yes. So it's now all 8 inch. Okay, so that is how you can go about creating, but it's sort of like cannot find the T. So later on, you have to put the T here and reconnect again. All right. So somebody asked me how to change the branch size. Okay, so this is how you can change the branch size. Okay. Okay, so with this in mind, I'm going to just delete away this branch so that it doesn't bother me. And then I go back to my my draw module again. Okay, so any questions? We are running ahead of time. I'm still quite fast with my with my modeling. if you have any questions, just please write. So just now I show you how I changed the branch size. Okay, the what are the dimensions of the component, etc. All is done in the catalog. All right, all is done in the catalog. Okay. So we are just on time at 4 o'clock. I'm going to talk about admin and all the things that you can come across in admin, and maybe that will answer your question on socket type, etc. All right. Okay, so now we are back into our draw module. Okay, and then we go to our Draw Explorer, and then we call our seminar registry. We call out our sheet that we do before, open it. Okay, and now what do we need to do? We just say, okay, this is the sheet that we had before. This was what it was before. And what we do, we say update, and we say update the everything for the sheet. Okay, so you can see, right? Oh yeah, I didn't move anything. Okay, sorry, just now I should have moved this so you can see the dimension change just now. But you can see that, this has got an A now. So really this is just, you see update and the second pump is there. And so you can just add the dimensions for the second pump as well if you want to. All right. So this is how you actually manage the 3D and 2D, because it's all integrated together. You can do some things like this quite easily. All right. So that's the drawing, everything. Any questions? Any questions in draw before I get out of draw? Any questions in draw before I get out of draw? Okay, while I'm going back to draw, I'm going to show you the relationship between the elements and the catalog and about the databases, admin, etc. All right, so that's why I just use draw as the basis to actually show you the difference. Okay. So remember, our project is called APS. Our system is called demo. Okay, so two things I want to show you now. Now we're going to administration. We're going to administration. There are two things I want to show you. Okay, so first thing that I want to show you is what type of customization is possible with the MTO. So if I start another section of E3D, I go into another project, and then I will show you what kind of customization that is being done before. So if you go into a project called TDS. Okay, so if you catalogs and then you put something inside and then you go into model. So this is quite typical. Is a what they call that is a cable tray manufacturer, and they have things like they want to put in covers, and the covers sometimes have got is broken down into two pieces, one piece, etc. So this is where the information is stored in the catalog, and we can extract those information so that it can be displayed together with the component. So for this case, the bolts, they are not very interested. They just basically count the number of components times the possible number of bolts. But we can go down all the way to the bolts as well. Okay, so we can even go down to show where all the bolts are, etc. All right. So okay. Okay, so okay, so just to show you something that can be done, some of the things that is possible that is not something that you have to pay like, out of this world to get it done. So for example, you have something like, so this is, for example, you look at some of the bands. So this is 70 FRP. So for example, you look at the band. So let's say you look at the bands. Okay, so you can see all the bands that are created here and some straight items, etc. So what this allows you to do is that if you go into the MTO, okay, you can say, okay, I want an MTO for one of the band. You add it here and you say individually, you create the MTO for the band. And of course, this can be exported to Excel file. Okay, this can be exported to Excel file. Or you can do a subtotal. That means you want to consolidate it into subtotal. So you have 27 items, but once you generate, it becomes 6 items. So these are the items with the numbers and the weights inside there. All right. So this is for one band. That's for one branch. So if you go up to the top, you can actually say remove selected, yes, and add this one, and you can generate for the whole pipe based on subtotals. Okay, so this allows you to export your MTO based on per branch, per pipe, per zone, per site. Anything is up to you, and you can consolidate it accordingly. Consolidate by branch or go even upwards and consolidate by pipe. Okay, it's also possible. So this is some of the things that you can do with E3D or customization by us. Okay, so what else can you do? For example, you can add a divider. Okay, so I say add a divider. Okay, so the divider, I want it to be at center, and I can say, okay, I say add to a particular tray. Okay, so unfortunately, this guy hasn't got the divider yet. So when you think that got divider, you can add divider. So all these things can be added and it can be output as a MTO list or a, what do you call that, or a MTO report. Okay, so another thing that you can do, for example, if I go to this branch here and I say add cover to branch. So this will add the whole branch with a cover. Okay, But the good thing about this is that if I go back to my MTO, and then I say add to MTO, I say, okay, I say subtotal up. Okay, so now you can see there will be things for your, if you look at the, here, you put the cover, CO, so you can see all sorts of different covers with the different things for the correct item. So these covers, they are just physically to show you where the cover is. They are not in detail, but they have enough information to be able to put it in the MTO for you. So when you talk about whether you can add additional MTO, yes, you can, as long as they can be linked in the catalog there. If let's say that thing is a fixed, that means this item always has got this additional item, or this item can change, you can also link it to the inside the design itself. Okay, so this is something that you can have. So I think this is one of the questions about adding additional items. So if you can add here, you can add the information can also be shown in the isometrics as well. Okay, but these are not standard, these are all customized application. Okay, so let's go on to the next item that I want to show you about. Let's go back to our APS project. Okay, so let's take a look at the piping. Okay, let's take a look at the piping. Just the piping will do. Okay, so if we make it smaller, okay, I'm going to start up another session to show you the catalog item. So I want to put it this one. Is it? Don't know. Okay. So now it's one side already. So let's start another section. Okay, so I go into my APS again and go into system. Okay, and now I go into the Paragon module. Okay, so with the Paragon module, I select an item here and I use the combine window and I queue the spec ref. Okay, so this is the spec ref. Okay, so in my Paragon module, I'm going to show you how this component is created. Okay, so why they choose the other screen to go into here. Okay, so now this is the Paragon module on the right side. Okay, so how do I actually put it on the right? Okay, so this is my Paragon module in the right side, and this is really too big. So tools, command, okay, how do I make this smaller? Okay, I have to drag this out and put it at the side here. Okay, so now I put this item inside there. You can find the item. And so this specification will show you all the thing about this item. It has got when you select it, which specs it belongs to, what is the description, etc., etc. But if you go in, you want to see the geometry, you can go into the head ref. And this itself will show you the geometry of the item. Okay. Okay, so the geometry of the item, one of the things you can see is a connection type. So you can see there are P points that is here. And this P point, this guy here, okay, if you go into the point set, and this guy has a connection type, which is the parameter 3. So this is a FBD. So you can call your connection any name, except the first letter must be F for French, B for Backwell, S for socket well, etc. So that the ISO symbol will come out correctly. But the rest of it, you can name it yourself. So with this information, it will then allow you to set up a compatibility list so that when you are doing the design, when you try to connect something that's not compatible, it will warn you. Okay, so this is how you can decide about your compatibility list. Okay, so I think that was one of the questions that you guys asked, is that the compatibility list. As to the dimensions, so these items here are all, if you go into the geometry, they are all also in terms of formulas. So when you go into the category, you can see that as long as you change any of these, the shape will change. Okay, so this is how you go about creating what you need. So you ask me how to convert a carbon steel pipe to a FRP pipe. If the outer shapes are the same, you can choose the same outer shape, and then you can decide like whether you want to make it the socket well a bit. You can put some more components inside there to actually sort of like so that you can check for crashes. So for example, this guy here, if you choose the profile obstruction, you can see that this is the actual crash volume that it checks against, not this profile detail. Because if you have a pipe running, a small pipe running through this hand wheel here, if you don't have this method, then what you will get, you will not get a crash. But this is not what you want, right? So what they have is that this will be the obstruction that the system will check against. So you are asking me whether it can check those bolts, whether the bolts can it crash or what. So you create an obstruction volume around the bolts, so that if not say around the bolt, that means the obstruction volume should cover the bolt, so that anything close by, they will tell you that it is too close or it actually crashes. So that was one of the questions. Does that answer your question? Okay. Okay. Okay, so this is the catalog and specs. So if you have the detail of the item, you can easily create a lot of items with the same detail but different dimensions. Sorry, any questions? Okay, so this is the thing. Okay, so now how to do the structure? Okay, so this is the structure, right? Okay, so again, you queue SPREF, and then you take this SPREF, copy and put it here. Then you go to CatRef, and you will see, if you go to Catalogue, you can see the structure profile. Okay, so this is, you can create any geometry, any shape, any profile that you want, and you can associate them with different parameters. Okay, so for this case, what AVEVA, what you can do, you can follow this, is to put in a set of 23 values. Some of them are 0 because they are not used. If they are used, they can be update to actually choose whatever that you want. So again, if you go to this item here, and then you go to the geometry, so you can see that this is called a profile, and then okay, if you click on the profile, so you can see that this is a profile element, and then you can see that these are all the points. All right, so these are all the points that you see around the element. Okay, so nothing to worry about catalog and spec. So the catalog gives you the geometry. The specification or the tables will give you your selection. I think one question that somebody asked me is that, what happens if you have other specs? Like for example, I don't know, you have a cabling spec, cable spec. But cable spec is very standard there, so there is a cable specs. So I can't think of any other specs that you have that is that may require, but you can have maybe you can have a valve spec so that you can construct valve or equipment spec or something. You can change the different components of the equipment, and then you can put them into a table form. Okay. Okay. Can somebody ask me some questions? Any questions? Or are you all muted or what? Allow participant. Oh, actually, there's an allowed participant to unmute themselves. Okay. I sorry. I didn't know there's an allowed participant to unmute themselves. So, anybody, any questions? No. No. Okay, last thing to do is to show you about the administration. So somebody asked me what is a database, etc., etc. So maybe this will answer the questions. Okay, so administration is not a module that you have to install separately. So on the user machine, normally we do not install the administration. So if you go into AVEVA administration, okay. Okay, so this is the project, and administration, you have to go in by the system username and password. Then you can get into administration. All right, so you can go into admin. Okay, I'm going to just close everything else. Okay, so what I'm going to do, I'm going to create a user that has no possibility to write into any of the database. Okay, and I want to show you how to create that user and how that user can be used. All right. Okay, so this is administration. So the first thing that we need to create is called a team. All right, the first thing that we need to create is called a team, and I create a team. And what do I call this team? I say semi, okay, semi for seminar team. Okay, I say apply. Okay, so I create semi for seminar, and I create a new user, also called semi. So I say semi go. Okay, semi go. And then okay, I say set password. Okay, and I choose the theme. So the theme is just now the one. I put it into a seminar theme. All right. So, and how to set password? So I put the password as caps S, okay? So the guy can change the password later on, all right? So if I say apply, okay, so now we have a user called SamiGo, and he has a password called S. Okay, so with that in mind, I say save work. Yes, save work. And now, if I start my E3D again, I will be able to go in as Sami. All right. So if I click here, Sami Go is there. And what's my password is capital S. Go to a demo, go inside there, and the guy can look around, but he cannot mess up your design. Okay. So this is how easy to put a new user into the system. Okay. After this, I'll show you how to create a playground for him to play. Okay, how to create a sandbox for him to play, basically. All right, so Okay, so this is our semi-user. Okay, so this is my seminar thing, right? I can go inside, bring the thing in. I can do measurement. I can measure distance between this item and this item. You can see a distance measure. Now, I think I want to move this. Move. You see? Nothing seems to happen, right? Okay, so this guy think that he's very smart because he know a bit of E3D command line, and he say by north 500. He says I cannot write to this database because I don't belong to the team that this database belongs to. So this is a issue. So you can meet semi go to be belongs to a team, or you can create him for a new MDB where he can be using to actually do things for himself. Okay, so how do I do that? All right. So unfortunately, I have to close this again. Okay, otherwise, okay. So now I'm going back to admin. So first thing what I do, I create a database for the semi team. So I say create a new database and I give it to the, okay, I want to give it to the seminar team. And I call this database -c design and I create, say, semi-world. Okay, so semi-site, etc. So, okay, so this creates the database. All right. So this is not Excel database, it's nothing. This is E3D database. If you create in a crowd, you will put in a crowd. If not, then it's so now the semi owns a database. So let's go back to our MDBs. Let's go to the demo one and say copy. And then we say a demo semi. All right, so this is the demonstration database for semi. And now we modify it. We add the semi database to the top, okay, and apply it. Okay, so now if we do a save work, so now our semi will have its own sandbox to play. Okay, so I just start my E3D again. Okay, semi go, this is capital S. And now instead of using a demo, I use a demo semi. Okay, so now he has his own sandbox to play. That means he can create his own equipment, etc. So for example, if this project is for all the isometrics in your company, everybody can use the same project, but they can go to different database and you give them permission. For example, you say team project ABC, then you create some project ABC databases that the team project ABC can use. All right, so you have you got 4,000. So every project you use 2 new databases, so you can have 2,000 databases. You can have 2,000 people to use for different things. Okay, using the same project. But if you have many projects, that's a different thing. Okay. So now I create a semi. Okay, so can you see the semi world here? And now you can go to, let's try equipment or, yeah, let's try cable tray, I think. Since we are at cable tray, must I try cable tray? Okay, anyway, let's start by creating a new site. CT site, okay. So you say, okay. unable to, okay, never mind. Because again, I have the auto name set up. So I say CT-site. Okay, so now it can create a zone, and now you can auto name it, and this is for cable tray. So electrical zone, okay. Okay, so my auto naming rules are not found there. How come my auto rules are not found there? Okay, never mind. Then we just have to do our thing manually. So we just rename it as CT dash. Okay, so let's call it CT zone. Apply. Okay, then we can go into our cable tray design. Let's check what is the cable tray specification that I need. Okay, so let's do I don't know, okay, do a Ventran or something like that. So let's do a Ventran. I don't know which is good actually. Oh, my outline is here. So let's do an outline then. Oh, this looks like a very old outline. This is not the latest outline. Huh? Okay, so let's do a Ventran then. Okay, so these are the, oh, what the hell? So many specs. So, okay, so these are all the standard specs that is inside the system. So I don't know which is the best to use. Okay, let's do a, I don't know what is this also. Okay, so let's create a cable tray. Okay, and call it CT-1. Okay, and then you will create a branch. Okay, and then you say where is the start point? Is it 0, 0? Maybe it's high up about 1, 2 mm. And then what's the width of the cable tray? These are the width available. Okay, apply. So input board. Okay, so just a minute, just because the cable tray is actually in mm, so I apply again. Input board is not a board value nearest. Okay. Okay, so whatever, I don't know, that's not my specification. So if I go into the component, and then let's create a fixed tray, forward, fixed tray. Okay, let's create. This is horrible. Okay, sorry. So this is the, let's delete this one again. Okay, so sorry. So I don't know what's wrong with the specification. So if I do, I don't know, she's good actually. Okay, let's do Outland FOE 100, maybe. So let's create cable tray again. Okay. It's a good habit to name things because then it's much easier. So now we have 150, so we have 450. So the direction is to the east and it's open, apply. Then next one, you can start doing your components already. All right. So you can see that there's a little thing here. Can you see that? So this is the start that I defined just now. So if I modify branch, I can put it up like, let's say, 1200 mm. Okay, apply. So you can see now the branch is a bit higher already, like your cable tray. So we create a fixed tray, and let's say we have a fixed tray, and then where's the tray opening is upwards. So that will give you the tray on the top, right? Can you see that? So let me just go into the options and I can see all. So then I can go in and create a band, let's say 90 degrees. Okay, and then create another band, let's say another 90 degrees band, and then say distance 4500. Okay, and then click on distance, and then you can say change axis. So you want to go this axis, and then you create another band, and then you can do 45 degrees, and then distance again. Okay, and then you can say where is the connect branch? Okay, so tier to last member apply. So now once that is done, you can do a field restrict. Okay, and so this is how you can create a cable tray. Okay, so so you can see that it's very easy for me to start a project with all the piping class, everything that you are quite used to, and we can start modeling, and then we can create drawings, etc. If you create drawing, again, you have to create a database for the draw for semi to use. All right. Okay, so I think we are ready. I'm ready to handle your questions. So can we start? Anybody with any questions? I can see that there are 12 people here, but there are no questions. Okay, Shamurajan, no questions. Anybody else? Oh, we're good. Okay, great. So, yeah, do you know a lot of people ask me a lot of questions? So take this opportunity to ask me any questions. Okay. So I'm always open to help people. So yeah, any questions? You can even ask me give you advice how to become a good E3D person. Just join TDS. Just join TDS training course. Hello, anybody? Or everybody wants to end the what you call it? End the meeting. We are half an hour earlier.
Do you have anything else to show?
Sorry?
Like, do you have anything other interesting that?
No, not. Okay. So if you have no questions, because actually this last portion is for you to ask question. So we have element and attributes, model structure, equipment, piping, cable tray, model check. So we did that. We do isometric, general arrangement, and reports. So now questions. So shall we end the seminar here? And will you be asking your friends to join the seminar next time if we have again? Or you have, okay, anyway, please write to us, to our coordinator. Okay, I'll send the coordinator emails to all of you. And then if let's say you have any comments, etc., and we might ask you for some comments. So if you have any comments, etc., you can let us know, and then we will try to get back to you. And okay, so shall we end here? Okay, so okay, so somebody say yes. Okay, so if you you have no questions for me, you can get offline, and then if anybody want to stay back and maybe ask me some secret question or what, then he can do so. Okay, shall we do that? Okay. Okay. So, but anyway, I have a question for you. Before you go, can you tell me, is this a good help or understanding demonstration? You think it's good? Can somebody say something or what? Oh, thank you for the information. Okay, so those who wants to leave, you can just end the meeting, and then those that want to I will stay here until the last person goes away. Okay, so so you have